Hi guys, myself Ankit. In this video, we shall see another problem on LeetCode. Search and rotated sorted array. So here is an integer array sorted in ascending order. So with distinct values, means unique values. So prior to being passed to your function, this array is possibly rotated at some index, unknown index like pivot index, let's say, such that the resulting array is shifted by k times. So what they say here is, for example, let's say this array 0, 1, 2, 3, 4, 5, 6, 7. It might be rotated at the pivot index 3, that is over here, and become 4, 5, 6, 7, 0, 1, 2. That means pivot index 3. So 0, 1, 2, 3. From here, all the elements have been rotated. 4 is rotated, 5 is rotated, 6 is rotated, 7. First 7 will move to front, then 6 will move to front, 5 will move to front, 4 will move to front. So it will be 4, 5, 6, 7. Later the remaining part 0, 1, 2 will be here. So this is the rotated sorted array. Why is it sorted? It was sorted already, but at some pivot index it has been rotated. So that's why it's called rotated sorted array. So given the array nums, after the possible rotation and integer target, return if the index of the target if it is in nums or -1 if it is not in nums. So our task is to check whether the element is present in array or not. If it is present in array, the target element is present in the rotated sorted array, then we have to return the index of that array. So here you could see 0, 1, 2, 3, 4. 0, 4 is the index. If that particular target is not present in the array, then just return -1. So normal approach when we look into this comes to here is a linear search, right? So I'll start from here, check whether 4 is equal to target, no. Then check for here, 5 is equal to target, no. 6 is equal to target, no. 7 is equal to target, no. Then 0 is it equal to target, no. Yes, it is equal to target. So return the index. So you return the index. But will this be a optimal solution? It will take a bit of n complexity because it has to iterate to the entire array once at the worst case. So will this be a better solution or optimal solution? No. See, in the question they have said it's a rotated sorted array. Sorted, whenever sorted comes to our mind, and you have to search in that, you have to find something, then the binary search comes into the picture. So in binary search is applied, the algorithm is applied only if the array is sorted, and it is also applied if you want to find something in that array. So here the same case, it's a sorted array, but it is rotated, but it's still sorted, and we have to search for the target element in the array. So let's see how we will apply the binary search method over here. Okay. So initial array was this, it was sorted from or rotated from till the fourth pivot index element 4. So that caused the array 4, 5, 6, 7, 0, 1, 2. Now let's see how do we apply binary search algorithm. Usually binary search what we do, we will have two pointers. One is pointing low, another is pointing at the end of the array high. And we should calculate mid. Mid will be nothing but low plus high by 2. So I'll mark the index. I'll mark the index and keep so that it will be 0, 0, 1, 2, 5, 5, 7, 5, 6. Yeah. So this is the index. This is the elements. So now we have to calculate the mid. What is mid? 0 plus 6 by 2. I mean low, high are pointed to the index, not the element. So 0 plus 6 by 2 will be 3. So mid is pointing over here. Now, can you apply the algorithm? Let's see now. Okay. So we have 7. So our target is 0. Target equal to 0. Is 7 is the target, 0 is less than 7. So that means in our normal binary search, that means it will be prior to mid. So what we do, high equal to mid minus 1. But here if we do high equal to mid minus 1, so in this case if I take low was here, high was here, then mid will be something at 4. So 0 less than 4. So what we do, high equal to mid minus 1 we do. Right. But here same thing if we do high equal to mid minus 1, if high is pointing here, so again we have to calculate mid. Mid will be over here. If we make high equal to mid minus 1, that indicates we are just neglecting this entire part. the right side of the array. But if you see here, 0 is present in the right side of the array. So this normal binary search approach will work in the sorted array, but in the rotated sorted array, it will not work. So we have to look for some changes in the code that we will see now. Now what we'll do is let us try with other method one. So we know that they set the pivot index, right? The index at which the element ascending or decreasing order changes. So if you carefully observe here, 4, 5, 6, 7 go on increasing. Then it once decreases over here, right? 7 to 0 it decreases, then again it increases. So this is the pivot part. So let's see what if we make mid equal to 0 now, the pivot part, or 7. Let's say target equal to 1 we need to find, okay? Or 0, let be 0. So let's say now anywhere we start iterating in the array, okay? 5 is less than 5 is greater than 4, okay? 6 is greater than 4, okay? 7 is greater than 4, but 0 is not greater than 4, 7. So at this point we'll make pivot as 7. So this will be mid. And let's high p pointing here and low p pointing here. Still the algorithm fails because 0 is less than 7, so high will be equal to mid minus 1. So still the algorithm fails. So we have to look for some other method. Let us see that. So again I'll point here. This is low and this is high. Okay. And mid is pointing here. Mid equal to low plus high by 2. I hope you all know the binary search algorithm. So this is mid. Now what we'll do is, if you carefully observe, if you carefully observe, the right part is rotated, not rotated, it's sorted. 4, 5, 6, 7, it's sorted. But I mean, it's the left part, very sorry. So left part is sorted, but when you come to right part, 7012, is it sorted? No. 4, 5, 6, 7 is sorted, but 7012 is not sorted. So that means, let's first check the sorted part. Okay. So 4, 5, 6, 7 is sorted. So we will neglect this part now. This part we will neglect. Let's check the sorted part. So how do we get to know which part is sorted or not? That is one more question comes here. So for that nothing, it's very easy. If array of low is lesser than or equal to array of mid, then of course it's sorted. Similarly for this part also, if array of mid should be lesser than or equal to array of high, then it will be sorted. So if I point here low, high and mid. So array of low is lesser than or equal to array of mid. Yes, it is. Then array of mid lesser than or equal to array of y. Yes, it is. So that means it is in sorted order. So if it is not in sorted order, some one of the part, either left or right part, will not be in sorted order. So that's why we have to check whether array of low is lesser than or equal to array of mid. If that is true, so here array of low is lesser than or equal to array of mid. So we have to perform some conditions. Similarly, else will be next part where array of mid is lesser equal to array of high. But here it is not. This is false. So this is true. Hence we got to know this part is sorted. So once you got to know this part is sorted, let's check whether the target element is present within the array or not. So how do we check whether target element is present in this part of the array? For that again, either 0 should be greater than or equal to low and lesser than or equal to high. Array of high. Right? So target. So again here check if 0 is present between 4 and 7, is 0 is greater than or equal to 4 and lesser than or equal to 7. It is lesser than or equal to 7, but it is not greater than or equal to 4. So that's why we can confirm that it's not present in this left part of the array. We can strike out this entire left part. Got it? So I'll explain once again. Low, mid, high we have. So first check which part is sorted or not. So for that you have to check whether low is less than or equal to mid. If it is so, then this part is sorted. Otherwise, this part is sorted. Either of the parts will be sorted. And one part will be unsorted. So once you get to know the sorted part, in that sorted part, first check whether the element is existing in the sorted part. How to check? Give the condition. Whatever target, it should be greater than equal to high, less than equal to low. If it is for here, it should be greater than equal to mid, less than equal to high. So that is what. So 0 is not present between 4 and 7, hence you strike out this part. We are striking this part means what we are making. We have to make low equal to mid plus 1. So here if condition I'll write. So if array of low less than or equal to target is less than or equal to array of high, not mid, high, not mid. If it is so, if this is correct here, no. So here again we come to else part. So what we do? Low equal to mid plus 1. So low equal to mid plus 1. So check change low. So low equal to mid plus 1. Low was pointing here. Mid was pointing here. So low will be mid plus 1. Now again we have to recompute. Low plus high by 2. How much? Here. Mid. 4 plus 6 by 2. 10 by 2 will be 5. So once you have here, now again check which part is sorted. First we will check for left part. Now you can check here both part is sorted. First we will check for left part. So here you could say array of low is lesser than equal to array of mid. 0 less than or equal to 1. Yes it is. 0 less than or equal to 1. Yes, it is. So that means this part is sorted. So now check again whether the target element what we need is present within this range. So 0, is it greater than or equal to 0? 0 greater than or equal to 0, lesser than or equal to 1. Is it true? Yes, it is less than or equal to 1 and greater than or equal to 0 also. So is it less than 1, greater than or equal to 0? So it is true. That means the element which we needed is present within this range, low to mid. So we can skip what? High now. So high will be nothing but mid minus 1. So here comes high equal to mid minus 1. So I'll erase high. Mid minus 1 means here only. And I'll erase mid also. Now you could see both high and low are pointing to the same position. So mid will be also at the same position because 4 plus 4 by 2 will be 4 only. And this condition will become true because array of low less than equal to array of mid. 0 less than equal to 0. Mid 0, it's true. Then check what again 0 is between 0 and 0. Yes, it is. So now high equal to mid minus 1 again you will do because 0 less than equal to 0 less than equal to 0. It is true here. So high will be mid minus 1. So mid will be pointing here. High will move to point to the next previous position. So now until we give while condition low lesser than equal to high. So now low is crossing high. At this point you can stop the loop and you could see the answer is pointing it mid. So you could return mid as the answer. So this is how we solve the problem. Or else before doing this also what we can do is we can check if array of mid is equal to target, then you can return mid directly. Then perform these two conditions. Even that also works fine. We can do that. Otherwise, do keep on doing this. And if you do not find the element, at last you return the minus 1. So this is the method. So for the else part, how it will be? The reverse of this entire program. So here else will be array of mid, whatever is it, that is less than equal to array of high. And so here you have to check if it exists between the mid and high range. So I have to take array of mid if it is less than or equal to target or less than or equal to array of high. So if this is true, then low equal to mid plus 1. If it is in this range, then low will be point to mid plus 1. Else high equal to mid minus 1. If it is not in this range, it will be in this range. That's why you make high equal to mid minus 1. So that is the pseudocode. So we will program this now. First we will have int n equal to nums dot length, then int low equal to 0 and int high equal to n minus 1. Next start with the while low less than equal to high. First we compute the mid. Okay, so for computing mid it's nothing but low plus high by 2. Next, check if mid array of mid is equal to target. We will put this condition. If it is, then just return the mid. Otherwise, what you have to check, if if it is not true, then you have to check if array of low less than or equal to array of, sorry, it's not array, nums of low less than or equal to nums of mid. So first this condition. So if it is true, you have to do something, else part also need to be done something. So at last you return -1 if the element is not present in the array. So first here we have to check if this is between the range. So if array of, not array, okay, nums of low less than or equal to target is less than or equal to nums of mid. If this condition becomes true, then high equal to mid -1. Otherwise, else you have to give low equal to mid +1. Similarly, else condition. For else condition will be nums of mid less than or equal to nums of high. So you cannot, we have to write this directly. You can check if the target is between the mid and the high. So nums of mid less than or equal to target less than or equal to nums of high. So if it is true, then you do low equal to mid +1. Else high will be equal to mid -1. Yeah. So if the array length is 1, then you have to change. So I'll do that also. Okay. Here instead you have to give and condition and target. Yeah, you cannot give like that. Here also. Yeah. So we will submit this. Yes, successfully submitted. For C++, it's all the same code. Instead of length, you have to give size. So if we need, I'll submit that also. Yeah, nothing else need to be changed. Yeah, you could see successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with other in the next session. Until then, keep learning. Thank you.